All right, so picking up with number 9 on our final exam review. When you have a problem like this where you need to find the solution and you got a rather ugly set of decimals and some distributing, you got positives and negatives ahead of you, of course you could distribute 2 rounds and then move variables to one side and numbers to the other, but we did look at other ways that we could lean on Desmos to help us with this. So one thing we could do is put the left side of our equation in Desmos as a y equals, and then we're going to type it in exactly how it's written. So 0.4 and then the parentheses, all that good stuff. So that's going to go in what we can call box 1. So one of the boxes in Desmos, we'll put that in on one side. On the other side, we'll put what the other half of our equation is. So we'll put the right side of the equal to sign into Desmos as well. And so I'm writing the y equals just so you remember to type it in as a y equals. And then that's going to go in the second box in Desmos. And it's going to feel a little bit like systems of equations because we're going to graph these in Desmos and see where the lines cross. So graph to see where lines cross. Okay, so that's going to be a Desmos. So clicking over to Desmos here, making sure you're using your star version of Desmos, we're going to type in y equals, and then again, exactly how we saw it. So you put the 0 on there, 0.4, and then 10x in parentheses minus 10, close our parentheses. So that's box 1. And then for box 2, we're going to type in the other side of our equation. And so this is, kind of a cheater way of solving equations, but, we're going to use our resources because the key here is we're looking for what value of x, right, where will our equations be equal? So kind of same premise as a systems of equations, but not to be confused with the systems of equations, because all we're actually after here will be the x coordinate. Because remember, after all, we have an equation and we want to know what value of x is going to make these two sides equal to one another. So it's an alternative to solving the equation by hand. But this is not your answer. Your answer is the x coordinate of that solution. So looking for the x where the two lines cross each other, we're going to say our answer is x equals a -2. Okay, so that would be one way of solving it without having to do all of our algebra work. So another problem, very, very similar, right? We could either distribute the -2, distribute the 4, combine like terms, and do all of that, or we could lean on our technology here, and we could put y equals that whole thing in box 1 in Desmos, and then we could put the right side of the equation, so y equals, and then all of that in box 2. So kind of one equation for the left side, one equation for the right side, and then when you come over here to Desmos, if I just clear out what I had from the previous problem, so I don't get confused, I'm going to take all of it out, okay, and then start again, but starting with y equals. So y equals 5x minus 2 parentheses 3x minus 4, so exactly what I see on the left. And then my second equation is exactly what I have on the right. And what I will be looking for, remember, the little house button takes you back to your home screen. I'm trying to find where these lines are going to cross each other. But because I'm not actually looking for a system of equations, it's like I'm using the concept of solving systems to see what value of x makes these equal. I really am looking, when it comes to like the multiple choice part of this, you're not going to see this ordered pair as an answer on your tests. You would just be giving us the x coordinate, so the value of x that makes them equal. Now, moving on to number 11. What we have here is another problem where you have a table of points on the graph of a linear function, and we want to write a function to model this relationship. So writing a function for a line means we just want that y equals mx plus b equation. But remember that whenever you have a table of values, we can use regression to get that equation. So we can let Desmos do the work on this one. And so let's go through what that would look like one more time to put this into Desmos to check the table to get our slope and our b value, because that will allow us to write that function that represents the line. So let's clear this out. To put in a table, you need the plus sign, and we want to enter a table. And so type carefully, starting with our x coordinates. We're going to have negative 6.5, and then followed up with negative 4.5, and then negative 1, positive 1, and positive 4.5. So then jumping over to our y column, we have a 3, a 1, a negative 2.5, negative 4.5, and ta-da, negative 8. So looking at this one, we can see that it's going to be a line, right? And so we have learned to write equations for lines by hand, but we also learned about the worm. So using the Y1, and I am just hitting the 1 on my keyboard, so just regular size 1 key, and then the worm. And so remember, you can find that key here. So you have to go into your alphabet to see it, but it's right here for the worm if you're trying to find it on your keyboard that way, or it's next to the 1 key at the top of your actual keyboard. But notice I'm having to put the 1 because remember, I'm telling it x1, y1. I'm saying use this information to create my line. And so looking at this one, I have a slope and a y-intercept. So it will generate that for us, negative 1 and negative 3. So then coming over here, I'm just recording, my m was a negative 1, the b was a negative 3.5, and so I'd be looking for the equation, because they're not going to show you that that's a 1, it's implied, but they're not going to show it, so that would be our equation for number 11. So run that regression. What is the equation of the line that passes through the point 3, negative 9 and has a slope of 0? Okay, every time you see 0 or undefined slope, I want you to bust out the HOI and the VUX, right? So 0 slope, that's HOI. Horizontal lines, 0 slope, y equal equations. Don't make it more complicated than it needs to be. See 0 slope, write down HOI, because it has to be a horizontal line. This part represents what the equations look like of horizontal lines. So those are y equals equations. So our equation for this line is simply y equals negative 9. And of course you could graph it and see it's going to be a horizontal line that passes through this point. So we're going to take that same idea and look at 13. What is the equation of the line that passes through the point negative 3, 5 and has an undefined slope? So undefined, that's our VUX, vertical, undefined, x equal equations. So x equals, don't overcomplicate it, right? X equals, it has to pass through this point, so it needs to be x equals our x coordinate of the point we want it to pass through. The next one, you have a couple of options on how you want to handle a problem like this. The table below represents the points on a graph of a linear function. What is the rate of change of y with respect to x for this function? So this is just a fancy way of saying slope, right? And we know slope is rise over run. So you can calculate what are you counting by, and then do that change in y over the change in x. So looking here at 19, so 19 going down to 5, that's a difference of 14. and it's going down. Our numbers are getting more negative or smaller. So counting down by 14 here, and from -4 to positive, or to 0, and then moving up toward positive numbers, we have a difference of up 4, right? So up 4 and then down 14. So we could look at just setting up our slope this way and reducing that down. This would reduce in the calculator. If we're not sure, we could always clear this out, and we can see that -14 divided by 4 is -3.5, or remember, this little key will switch to that that fraction for us. So you can see that it's -7/2. But let's say that you don't trust yourself. You can run regression on this as well. So we could go back and put in that table, -4, 0, 2, and 6. And then in our y column, 19, 5, -2, and -16. And so we need the worm, right? So y1, worm, and x1 plus b. You have to tell it that data. Now, I don't really care about the y-intercept here. I just need that rate of change. So look, -3.5. That's the same slope as that -7/2. So -3.5. If you put that in and needed to change it to a fraction, that key will do it for you. But either way, by hand or using our regression, you should be able to come up with your slope. And so whether it's in decimal form or fraction form, you are equipped to figure out what's equivalent there. Now for your x and y intercepts, this one we're just saying, what are the x and y intercepts of each graph? And so just keeping in mind that your x-intercepts are going to be where you cross the x-axis. And so x-intercepts, I'm just going to mark them. So an intercept just means, that's that crossing place, the place where it touches. So x I'm going to do in pink, and then y I'm going to do in green. But I do want you to be careful to not mix them up, because I know everyone can do this if you just slow down and take it in little pieces here, so you don't mix up your signs or where your zeros should go. But we're not just going to say that this is x equals 4. Intercepts should be written as ordered pairs. So this would be the x-intercept of 4, 0, and a y-intercept of 0, 5. Okay, so where you cross y, notice that the x is the one that's 0 and the y has the number, and then it's just the opposite when you're looking at your x-intercepts. So this one, for an x-intercept, the x is -1, 0, and then our y-intercept is 0, 2. X-intercept here would be 1, 0, y-intercept, and this one's kind of hard to read, but 0, I'm going to go with -5 on that one. Might be -6, kind of hard to tell. On this one, this is going to be a -5, 0 for that x-intercept, and that y-intercept being 0, -2. So just careful to see which one it asks you for, because you don't want to give the wrong answer depending on if it only asked for one but not the other. Okay, and so last one for this chunk of review problems, we're going to look at graphing the inequality. And we have y is less than 1/2 x plus 5. So remember that Desmos can graph the line, but we have to use y equals whenever we work in our star testing mode version of Desmos, because it won't put in that little less than symbol. So it's not going to do the shading for us when we're using the correct version of Desmos. Of course, hopefully you recognize that you have a y-intercept at +5, and you have a rate of change of 1/2. So that's up 1/2, up 1/2. But remember, whenever you have an inequality, you have to think about, do I have a solid or a dashed line? And then what should my shading be? So on this one, because of the less than, we are going to have a dashed line because we don't have that equal to bar. So the numbers along this line won't be included in our solution. But we also need to think about the shading. So because it's y is less than, we're going to shade below our line. So we before we connect this, we want to make sure that we know, okay, we're going to have a dashed line. And so we're going to just show that there's some breaks in our line. And then as far as the shading goes, we're going to be shading beneath our line. And so if you get confused by that, pick a point on your graph and ask yourself, if I go up versus down, right? Up for above, down for below, which region would I fall in? And so again, though, if you get, don't let the line trip you up. We can clear all of this out. We can use Desmos to graph the line itself just to make sure that everything ends up in the right spot. So that's what our line should look like, and that is what we have on our papers. Although we know it's dashed and we know we need to shade the region below it. And if you don't believe me, if you try to put in the less than symbol here, notice what it'll tell us. Plotting inequalities is disabled. So Desmos will only take us so far as the graphing. We have to be able to get the rest. From here, maybe this is what the question's asking, but we could also be asked about are certain points solutions. So the point 0.5, is that a solution? Well, if we go to the point 0.5, at first it feels like, well, yeah, it's on the line, but it's on a dashed line. So no, the point is not a solution if it's on a dashed line. That means those points are not included in our solution set. Now the 0.11 is definitely in there, right? It's inside of our shaded region, so that's going to be a yes. And then the point -510, so that's going to be like way up here somewhere. That's going to be a no because it's not in the shaded region.